So what definitively does happen at a max or a min? What makes a max or a min happen at a critical point? All right, well, what's going on with f at a minimum? F is decreasing, and then f is increasing. Whether we're at a horizontal tangent or an undefined point, or a point where f prime is undefined, f has to be decreasing and then increasing. If you think about it, that has to happen at a min. So at a min, f has to change. F changes from decreasing to increasing. So if you think about how f is related to f prime, that means that f prime changes negative to positive, which we've already talked about in the graphing context, right? So we already know that if f prime changes negative to positive, then f has to have a min. And we can really take advantage of that now analytically instead of just graphically. So when I'm looking at a max, f is increasing and then f starts decreasing. That's what happens at a max. F is going up and then starts going down. Even if f prime is undefined, f is increasing and then f is decreasing. So at a max, f changes from increasing to decreasing. All right, so what that means is that f prime changes from positive to negative. In fact, these are going to be the justifications for a min or a max of a function. All right, so if we want to find the maxes and mins of a function, so to find relative max and min, here's what we have to do. We have to, one, find all the critical points. And there might be more than one. Find all critical points. Then we need to examine the behavior of the sign of f prime at the critical points. So this process that we're going to do, where we compare whether the f prime does this, changes negative to positive, positive to negative, or maybe it doesn't do either of those things. All right, that examination has a name. It's called the first derivative test. A process that we will use so frequently that we will often abbreviate it, the FDT, the first derivative test. Okay, so without further ado, let's try to do some of these. So, there's each one of these has a lot of considerations around it. It's very contextual. You're going to learn by doing. So I'm looking at your textbook, page 194, and I'm going to be looking at number 14. So here's number 14. The directions say, use analytic methods to find the extreme values of the function on the interval and where they occur. Now, each one of these gives a function and an interval. Now, I picked number 14 first because the interval is negative infinity to infinity, so there is no interval. We just want to find all the max and mins of this function. And then next, we'll talk about what happens with these intervals. Okay, so for right now, I want to look at this e to the negative x squared, and since the interval is the whole real line, we're just looking for all the maxes and mins. Now, e to the negative x squared is also a cool function to start with because we don't know what that looks like. All right, I know what it looks like. Maybe you know what it looks like. If you do AP Stats, you will use this function a lot, and you already know what it looks like. And in calculus, you're going to learn some important properties that it has. Okay, but if you haven't had AP Stats or you haven't gotten to that, I forget what they call it, normal distribution or something like that. Those stats people, who understands them, not me. Anyway, we want to know if this thing has, maybe it doesn't have any maxes or mins. Maybe it has some maxes or mins. I don't know. So here's what we do. So first we're going to find the critical points. So find all critical points. All right, so that means we have to find k prime of x and see where it's equal to 0 or undefined. All right, so what's k prime of x? Well, this is a chain rule. So derivative of the outside function is e to the negative x squared, keeping the inside function the same, times the derivative of the inside function, which is negative 2x. All right. Now, I want to solve where that is equal to 0. Now, this example is a great example of something the AP exam likes to do a lot, and it's actually a really good thing to be aware of. We have a product of two factors, and that product has to equal 0. So an important thing to know is that e to the power of anything, any expression at all, is always positive, right? You know this from the graph of e to the x. E to the x looks like this. So it doesn't matter what we do e to anything. If I do e to something, I'm never going to get 0. Therefore, this factor is never equal to 0. So in particular, e to the negative x squared is never equal to 0. Therefore, the only possible solutions to this equation are that the negative 2x has to be 0. Right? That e to the negative x squared is never going to be 0. So how could this whole thing be 0 if negative 2x is equal to 0? All right, so then we get x equals 0. So that's our only critical point. So we might want to observe x equals 0 is the only critical point of y equals, I guess it was k of x, Okay, so now I know it's a critical point, but is it a max, is it a min, or is it neither one? You know, maybe it's something that, you know, does something like this, you know, or maybe it is like an point where f prime, well, it's not undefined, we know it's 0. So it could do this, right? We could have a horizontal tangent that's not a max or a min. Okay, so what we're going to do is this second part, we're going to examine the behavior of f prime. So we're going to do what's called the first derivative test. So what we're going to do is we're going to take this critical point x equals 0, and we're going to look at what happens when x is less than 0 and when x is greater than 0. Now here's the thing to be aware of as well. A lot of our early examples are going to have their critical point at x equals 0. The critical point does not have to be 0. If the critical point was 2, then I would be looking at x less than 2 and x greater than 2. So it's not about x being positive or negative. It's about x being to the left of the critical point or to the right of the critical point. All right, so what is k prime of x in each of these cases? Well, when x is less than 0, k prime of x is equal to e to the negative x squared times negative 2x. All right, I just copied what it was, okay? Now what you do is you perform a sign analysis. What's positive, what's negative? All right, so we already observed that e to the negative x squared is always positive. This is positive. If x is a negative number, then negative 2x is a negative number. K prime is a positive times a negative. That means k prime of x is negative. All right? What about when x is past the critical point, x is greater than 0? Then k prime of x is still equal to e to the negative x squared times negative 2x. I like to write it twice when I'm organizing my first derivative test, just so I sort of have something to analyze on each side. Now on this side, once again, e to the negative x squared is still always positive. But when x is positive, negative 2x is going to be negative. Now k prime of x is a positive times a negative, so k prime of x is less than 0. So what I can say now is that k has, well, let's see, k prime changed from negative to positive. So what does k have? K has a min. K has a min at x equals 0 because k prime changes from negative to positive there. All right, so be specific about what you're saying. You can't just say because it changes from negative to positive, okay? K has a min because k prime changes. We can't say it has a min because it changes negative to positive, right? No it's. All right, k has a min because k prime changes negative to positive there. All right, now we also know that that is the only critical point that k has. So that's all it can have is a maximum, right? That's all it has. Now you can do a little bit more analysis on the graph of e to the negative x squared. You can find what the limit as x approaches infinity is, and the limit as x approaches negative infinity. As x approaches infinity, this x squared is going to get very positive, very large, but negative. So I'm going to have e to a negative power. It's going to be a very small number. So this expression is approaching 0 as x approaches infinity. And since the x is squared, this expression is also approaching 0 when x approaches negative infinity. Also, the value at x equals 0 is 1. So that's this point where the maximum is 0, 1. All right, so now I know everything there is to know about this graph without having graphed it in a calculator. It has to approach 0 in both directions. So that's what that graph looks like. And you can graph it on your calculator and you'll see that is in fact what it looks like. Okay, so the power of this is I'm able to do this analytical analysis, and as a result of it, I know everything about that graph without having put it on a graphing calculator. So that also means that if I put it on a graphing calculator and I see this, okay, I know that I'm seeing everything, right? I know everything that happens forever, which is what your graphing calculator can't tell you. Okay, more examples to come.